Hi guys, this is part 2 of what you need to memorize for the EOC that is not on your reference sheet. So, on the end of course exam, you need to understand the difference between congruence and similarity. You must have this difference memorized because it will appear across multiple questions. When two figures are congruent, that means that the angles are also congruent, and so are the sides. In other words, each angle in one figure will be the same as an angle in the other, and each side in one figure will be the same as each side in another. So if you have a congruence problem, chances are you're probably setting two things equal to each other. By contrast, with similarity, there's actually some similarities and differences. So the angles are still congruent. However, the sides are not. The sides, and this is important, this is a key word that we must have memorized. The sides are proportional, okay? If you want an easier way to remember this in plain simple English, congruent figures are the same size and the same shape, right? They haven't changed. They've just changed where they're located, but they haven't changed. By contrast, similar figures are same shape, but different size. Bigger if it's an enlargement, smaller if it's a reduction. Okay. Quadrilaterals. You guys are responsible for memorizing and being able to apply the properties of parallelograms. What do I mean by that? What shapes are you responsible for? Parallelograms, rhombi, rectangles, and squares. You are not responsible for trapezoids, and you are not responsible for kites. So please don't stress yourselves out trying to memorize those and forgetting to focus on the important bits. So let's go through this together. I'm going to suggest, guys, that you memorize these properties visually. There are 5 properties of parallelograms you must know. 2 pair of opposite congruent sides. 2 pair of opposite parallel sides. That's the middle school material. Opposite angles, the ones in the corners, are congruent. The angles that are next to each other, the adjacent angles, because they're consecutive interior, they are supplementary. And last but not least, the diagonals bisect each other. On the exam, they may actually expect you to know that bisect means to split into 2 equal parts, and at this point right over here, right, which is kind of in the middle, that would represent the midpoint of the diagonals. Now, quadrilaterals come in different, or I should say parallelograms come in different flavors. So we have a rectangle on the one hand, and we have a rhombus on the other. The rectangle has all the properties of a parallelogram plus 2 more. The one we know from middle school is that all rectangles have 90-degree angles. But the other property we need to know is that their diagonals are congruent, meaning their diagonals are exactly the same length. Here's how I need to represent that. I need to represent that as each piece of the diagonal is the same as every other piece. Why do I need to do it this way? Well, I need to do it this way because it may come across on the exam that I need to apply isosceles triangles and their properties, namely that base angles are congruent. For the rhombus, the middle school property is that it's equilateral. All 4 sides are the same. Now, for geometry, we're expected to know a couple more things. First, we need to know the diagonals are perpendicular to each other, meaning they form right angles. Second, we need to know that the diagonals are angle bisectors. That means they cut each other, or they cut the angles in the corners into equal parts. And if I have a rectangle that gets together with a rhombus, that kind of like hybrid is called a square. So squares are equilateral and equiangular. And because their diagonals are like the diagonals of a rhombus where they're angle bisectors, we're going to know that each angle in the corners, right, is going to be 45 degrees. You can choose to memorize this as a list of properties, or you can choose to memorize it as a diagram. But speaking for myself, I generally find it easier to memorize it as a diagram. I memorize better visually than I do with random lists of properties that no one really cares much about. You didn't hear that from me. Okay, now let's talk trig. You do not need to memorize SOHCAHTOA. SOHCAHTOA is on your reference sheet. They will tell you that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What they will not tell you is this. You must know that sine of an angle, so we'll say sine of A equals cosine 90 minus A, and that cosine of an angle is equal to the sine of 90 minus the angle. That's called the complementarity of sine and cosine. We've seen this in problems where we have to take the two parentheses, add them together, and set them equal to 90. But in a multi-select question, that would show up. In addition, we need to make sure we know the difference between regular trig and inverse. Regular trig, sine, cosine, and tangent, are used when we're finding sides. So if what I'm being asked to find is a side in a right triangle, I would use regular trig. By contrast, I would use inverse trig if I'm trying to find an angle. If I'm being asked to find an unknown angle in a right triangle, use inverse trig. Sometimes you won't even need inverse trig. Sometimes you could just do it using triangle sum theorem. But if triangle sum theorem is not giving you enough to work with, use inverse trig. Okay, it goes without saying that you guys need to know the Pythagorean Theorem, a squared plus b squared equals c squared, and that you guys need to know that it corresponds to right triangles. You use the Pythagorean Theorem if they give you two sides. So let's just take a look at a quick example here, right? You use it if they give you two sides of a right triangle and you're asked to find the third, okay? The important thing to note is that the long side, the one across from the 90, is my hypotenuse, and I have to make sure that I use that as my C. Okay, let's talk circles. Oh gosh, circles. What must we know? Okay, so we need to know that the area of a circle is pi r squared. And we need to know that the circumference of a circle is 2 pi r. They may ask us problems that require the use of those two formulas. But in addition to that, guys, we need to know that because a sector, the area of a sector of a circle, is going to be a fraction of the area, so theta over 360 times pi r squared. And if they ask us instead for arc length, which I'm going to call L, that's going to be a fraction of the circumference, okay? So there are no ifs, ands, or buts. You must memorize the area formula for a circle and the circumference formula for a circle, okay? Because they form the basis for the area of a sector and for arc length. You also need to make sure that you guys know the basic equation for a circle. X minus h squared plus y minus k squared equals r squared. Most likely on the exam, they're going to ask you guys to know how to find the center and the radius of a circle in that form. But as we've talked about in class, they're going to force you to complete the square twice first before you can actually find it. But you do need to be familiar with that equation. Okay, what else? Let's talk about the 10 million circle theorems they could hold you responsible for, shall we? Okay, so in a circle, there are 360 degrees. If instead what I'm talking about is a semicircle, I need to know that it has 180. If I have what's called a central angle, right? A central angle is the same as its arc. However, if instead I have an inscribed angle, that means the angle has the vertex or the sharp pointy bit touching the circle, that is half the arc. Those are going to show up quite frequently. If I have an inscribed quadrilateral, I'm just going to label this A and I'm going to label this B, I need to know that the opposite angles add to 180. That's a little different from parallelograms, right? But if I have an inscribed quadrilateral inside a circle, it's got to add to 180. Then there are a whole bunch of like random theorems that I'm going to talk about really briefly because they may show up, they may not, but if they do, oh gosh. Okay, so if I have intersecting chords inside a circle, I need to know that the product of their pieces, A times B, equals the product of the pieces of the other one. If I have intersecting chords and what they're asking me instead is they're asking me to find, let's say, an interior angle here, what I need to know is that this angle is the average of the two arcs, or I could say it takes two of that angle to make the arcs added together. Sometimes, instead of having angles inside a circle, I'm going to have angles outside a circle. Oh joy, right? So, one of those situations is if I have a diagram that looks like this, okay? I'm going to label this A, I'm going to label this arc B, and I'm going to label this C. So in this case, what's going to happen is that it's going to take two of the angle outside to make the difference of the arcs. So 2A equals B minus C. By contrast, if what they're asking me instead is something to do with the lengths of these secants, or the lengths of these tangents, let me call this A, B, C, D, this is what we call exterior times whole, right? So A is the exterior, and the whole thing is A plus B. C is the exterior, and the whole thing is C plus D. We also need to know the ice cream cone problem, right? Draw an ice cream cone. In formal geometric language, if I have two tangents that intersect outside a circle, they're going to be congruent to each other. And I need to know that if I have a tangent, it's going to be perpendicular to a radius at the point of tangency. On the exam, what would that look like? It'd probably be like, what's this angle? And you're like, oh my God, it's 90 degrees. Big deal. Okay? Okay, so that is circles. Last but not least, hopefully before my phone dies, let's talk about volume. So, what do you guys need to know in terms of volume and surface area? Well, for volume, you guys need to know the following. You need to know that V equals area of the base times height. They're going to give you that on the exam, but they're not going to tell you what it corresponds to. You guys need to know that corresponds to a prism, and it corresponds to a cylinder. By contrast, if they give you V equals 1/3 area of the base times height, what you need to know is you need to know that that corresponds to the cone and the pyramid. As far as the area formulas that you guys are going to need for the area of the base, area of a circle comes up a lot, area of a rectangle, area of a triangle come up a lot. So you guys need to make sure you know the area of a rectangle is base times height. You need to know that the area of a triangle is 1/2 base times height. Okay? And for those of you guys that are like super committed to getting like every single question on the exam right, I am going to write one or two more things on here. Remember I told you guys that for cones, right? If we wanted to do the surface area of a cone, the base is easy. It's pi r squared. But the lateral area for a cone, the part that gets wrapped around, that actually has a formula which you might want to memorize. So the lateral area of a cone is represented by pi r L, where L represents the slant height, which means instead of going straight up and down, it's going to go kind of like sideways along the cone. And last but not least, we need to remember density. Density comes in two flavors. If we're going to use the chemistry density, it's going to be D equals mass over volume. And if we're going to use population density, so population density, that's going to equal population over area, or population divided by land area. Now, of course, guys, there's some stuff that I haven't really delved into too deeply. I didn't really go back into how to complete the square. I didn't really go back into how to partition line segments. But overall, if what we're looking for is we're looking for a way to kind of cram for the test, what we've gone over in these two videos should get you there.